So today we'll focus our attention on definite integral. Okay. In our last class, we learned how to deal with indefinite integral. Okay, antiderivatives. Okay, let us recall. So in our last class, what we did is antiderivative or indefinite integral. So something like we are given a function f of x dx. So that's what we did, right? These kind of function we found. For example, if we are given, let's say x squared dx, for example, then how we solve is that it is x cubed divided by 3 plus c, right? Using the power rule. That's what we did. Now, definite integral what does that mean? It means, let's say we have some interval here for x, so a to b, for example. So this kind of integral is called definite integral, and this a is called the lower limit, and this b is called the upper limit. Okay, remember the function must be continuous in order for this to be, in order to be integrable. We already know from calculus 1 that, even if we want to find the derivative, the function must be continuous at that point. So we consider f of x to be continuous on the interval a to b. And if I write definite integral from a to b, what does this mean? What is the meaning of that? It's important. So what it means is, let's say, let me just write one example, simple example. Suppose I write, let's say, 0 to 2, for example, x squared dx. What does that mean? Okay, it's a definite integral. The lower limit is 0 and the upper limit is 2, and we have a function x squared dx. What it means is, so the meaning of this is, x squared, draw the graph of x squared, which is a parabola opening up, right? So the parabola opening up, this is the graph. This is x squared, okay? F of x equals x squared. This is the graph. And 0 is here, and 1 is here, 2 is here, let's say. So okay, this represents this area. Okay, from 0 to 2. So it's under this curve, under f of x, from 0 to 2. So it represents the area. Keep that in mind. Definite integral represents the area. Now, let's quickly review one concept from high school. Okay. So the notation that we'll be using here is summation notation. Okay, summation. So we use this sigma notation. I think you guys are familiar with this. So for example, if I write, recall from your high school, I want to take you to high school just for a few minutes, and we recall this idea of summation. Let's say if I have 3i, for example, and I from 1 to 4. What does that mean? What it means is 3 times 1 plus 3 times 2. Remember, I is from 1 to 4. So plus 3 times I is 3 plus 3 times 4. This represents the sum of all of these numbers. Okay, so we, instead of writing all of these, then it's nice to just write this, it's really shortcut, right? We can actually put them in a concise form using the summation sign. So let's say we have a series like f of x1 delta x plus f of x2 delta x plus f of x3 delta x plus f of x4 delta x plus f of x5 delta x, and all the way, let's say we have f of x 100 delta x. So how do we write that? Well, what we can do is we can simply write it is f of x I delta x, and I runs from 1 to 100. Okay, we can represent all of these writing up to 100 just using the summation symbol, right? It's so nice, isn't it? Okay, so we'll be using that. Now, the high school concept, that's what you need to recall. Now I'll bring you back to the integral calculus course here. Now we know that definite integral represent the area. Now let's look at the area for different figure here. So if I give you a rectangle and if I ask you find the area of the rectangle, it is a piece of cake for you. Everybody know how to find the area for rectangle because this one is L and this one is, let's say, width W. So the area is L times W. Everybody know that. We learned from high school or even middle school geometry. And from geometry, if I give you a triangle and if I ask you find the area of the triangle, and it's not a big deal, you can find it because you know the formula of area of a triangle is base half base times h, right? If I ask you find the area of this figure, then what you can do is it's a penta, it's what, 1 2 3 4 5 6, it's a hexagon. So what you can do is you can divide this hexagon into different triangle, and you know how to find the area of a triangle. You find the area of this guy plus area of this triangle, area of this triangle, area of this triangle, and you add them all. So you can find it just using geometry. You can find the area of this hexagon. Now the problem is if I ask you what is the area of this S, how do you find it? Okay, all of a sudden your high school geometry collapse, right? You cannot find the area using the high school, exact area using the high school geometry. And so that's the power of calculus, guys. We know now, we will know how to find the area of this. As a matter of fact, if you know the function and if you are required to find the area of all of these, let's say area of this part, and if you know this, what is that function, then you can find the area using the calculus. That's what we're going to learn today. Okay, that's the main goal. Now let us suppose that we don't know integral calculus yet, so we just know the high school geometry. Now, using high school geometry, you can get approximate value, approximate area. That's what we want to begin with, okay? So one way to find the approximate area is you divide it into different rectangles, okay? So I divide this into 1, 2, 3, 4, 5 rectangle, and now what I can do is I can find the area of a rectangle, and I know how to find the area of a rectangle. If let's say this one is delta x, it's a small change on, a small distance on x side. So I represent this width of the rectangle by delta x, and the height will be f of a. And this height is, you can find the height of this rectangle. So the area of the first rectangle is delta x times f of a. In the same way, you can find the area of this rectangle by multiplying this delta x and height of this rectangle. In the same way, you can, multiply this width delta x with the height of the rectangle, and you add them all. So this way, we can find the approximate value. but finding approximate value is okay, right? Mm, it's better than not being able to find the area at all. So we can actually find approximate value. Now let's use this technique to find the approximate value of a couple of figures here. So let's look at this example one. Let A be the region bounded by the graph of f of x equals 1 over x, the x-axis and the vertical lines at x equals 1 and x equals 5. Now let us draw the graph. How does it look like? If I draw the graph will look like this. I'll draw here maybe. So I trust that you know how to draw the graph of this function. And this is, it looks like, because we are interested from the from x equals 1 to x equals 5, our domain, our interval is 1 to 5. So let me, this is my f of x equals 1 over x. That's the function. And 1 to 5. So 1 is, let's say this is my 1 and this is 5. Okay. 1 to 5. All right. Now we want to approximate the value. So how many rectangles do you want to divide this area into? It depends. Sometimes in the question, it will tell you how many rectangles you need to suppose. But here in this question, it doesn't say anything. But for simplicity, to make our life easy, let me suppose that the number of rectangle equals 4. Okay. If you want, you can suppose number of rectangle to be 5, 6, 10, 100,000, doesn't matter. I just want to give you a technique. Okay. To make life easy, let us suppose that the number of rectangle that we want to draw, we want to consider is 4. Okay. Here we are given f of x is 1 over x, and the interval is this a and b. The interval is 1 and 5. I assume this to be my interval, the point a and b. And then let us suppose that for simplicity, for simplicity, let us consider 4 rectangles. So that means n equals number of rectangle, n equals 4. Let us suppose that. Now let us make 4 rectangles here. If I make 4 equal width rectangle, then, so this is my first rectangle, I will draw there and there. So these will be the rectangle, 4 rectangle there. So my goal is to find the area inside that. Okay, this is my goal. And I decided to consider 4 rectangle and find the approximate value. Now you know that if I divide this into 4 rectangle, so this point will be 2, this point will be 3, this point will be 4. So what I mean is the width of the rectangle, we denote that by delta x. Delta x is 1 actually. How do we know that? Well, you can think this way. Width of rectangle equals, we denote that by delta x equals b minus a over n. So this is the formula to find the width of the rectangle. So if you divide this into 4 rectangle, your width will be 5 minus 1 over 4. So that's going to be 1. But if you want to divide this into 5 rectangle, then the width will be different. If you want to divide this into 10 rectangle, your width will be different. So you can use this formula delta x equals b minus a over n to find the width of the rectangle. All right. Now the question is, in order to make the rectangle, there are a couple of ways to do it. One way is, so to approximate the area, we use three methods here. Okay, so method number one, using left endpoint. What does this mean? So what it means is, you see this rectangle has one side is this, which is on the left side, and this one is right side. Can you see that? So this one is the left endpoint and two is the right endpoint for that first rectangle. So you can choose left endpoint, or you can choose right endpoint, or you can choose even middle midpoint. But in method one, we choose the left endpoint and we make a rectangle. In method two, we choose the right endpoint and make a rectangle. And method three, we choose the midpoint between 1 and 2. Okay, let's do this three ways. So using the left endpoint, my rectangle will be this. So this is my height. So I need to draw the rectangle using that height. So for the second rectangle, the left side is this. So the rectangle will be this one. And for the third rectangle, the rectangle will be this. The fourth rectangle will be this. Okay, so we find the height here. So this height will be f of 1, this height will be f of 2, this height is f of 3, this height is f of 4, and this one is f of 5. Okay, so basically what we need is area is approximately, area of sum of area of 4 rectangles, right? That will be the approximate area. We know that this is not the exact, but approximate, that's what we are trying to find. So let us find the area of the first rectangle, which is f of 1 times delta x, plus the second one is f of 2 times delta x. Third one is f of 3 times delta x. And the last one is f of 4 times delta x. So area of the first rectangle, second rectangle, third rectangle, fourth rectangle. Later on, to be more general, I'm going to use this. I'm going to use the first one. I want to start with x naught. I will suppose that to be x1, x2, x3, and x4. Okay, I can do that as well. So if I do this, then I can also write that area will be f of x naught delta x plus f of x1 delta x plus f of x2 delta x plus f of x3 delta x, right? So I can do that. So if you want to use the summation notation, you can actually write I runs from 0 to n f of xi delta x. You can write that way too. Okay, now let us calculate the value. What is f of 1? Let me just make a table here, x and f of x. So f of x is 1 over x. So when x is 1, my f of 1 will be 1 over 1. When x is 2, f of 2 is 1 over 2. When x is 3, f of 3 is 1 over 3. When x is 4, f of 4 is 1 over 4. And when x is 5, this will be f of 5, which is 1 over 5, right? So that's what we need. Now let us substitute the value. F of 1 is 1. times delta x is 1, we already calculated right there, plus f of 2 is half, delta x is 1, plus f of 3 is 1 over 3, 1 over 4, 1. I want you to calculate this and let me know what is the value all together. You can tell me in decimal notation. So when you add all of them, you're gonna get 2.083. Okay, that's the approximate area. You know what, this, because we're using the left endpoint, the standard notation for this is we'll use L4. Maybe I can write this way, hold a second. Maybe area is approximately, let us represent that by L4. L represent the left endpoint, we are using the left endpoint, and 4 represent the number of rectangle 4. So we are approximating the area using the left endpoint and considering 4 rectangles. So this is L4. That's the standard symbol that we'll be using. Okay, so that's the answer. Now my question to you is this: do you think this answer is more than the actual area or less than the actual area? Of course this is more, right? Because you see from the figure there are some part which is not in the saddle region, we have added them. So this is more. It's called overestimate. Okay, so note that L4 gives, note that, let me write this way, note that f of x is a decreasing function, and so L4 is the overestimate. L4 gives overestimate of the area. Okay, if it is increasing, then L4 gives you the underestimate. Because the function is decreasing, we have seen that there are some chunk of the rectangle that we have added, so it gives us the overestimate. Okay, now let's consider the right endpoint now. So that's method 2. So method 2, using the right endpoint. Using right endpoint. So if I use a right endpoint, I will represent that by R4. Okay, R4 is equal to sum of the rectangles, sum of the 4 rectangles with right ends. So that means, let me draw the graph again. This is your 1. And this is 5. 2, 3, 4, 5. So we have this, we want to find the area, this area right there. Okay, so this is your 2, 3, 4. Now if I consider the right endpoint, remember the right endpoint will be, so for the first rectangle, this will be my rectangle. Okay, I use the right, so the right side, right endpoint is this 2 for the first rectangle. So the rectangle will be this. I'm talking about this part right there. Okay, that's our first rectangle using the right endpoint. The second rectangle will be this. This is our second rectangle. Third rectangle using the right point is this. Fourth rectangle using the right point is this. So let us calculate the area. Okay, so here your right endpoint is basically, and this height will be f of 2. So f of 2 times delta x plus f of 3 times delta x, f of 4 times delta x plus f of 5 times delta x. So these are the four rectangles. And if you want to write this in a general form, you can actually represent that by x0, x1, x2, x3, x4. So some people write this as f of x1 delta x plus f of x2 delta x plus f of x3 delta x plus f of x4 delta x. Or also, if you want to use the summation sign, you can write I runs from 1 to 5, sorry, 1 to 4, 1 2 3 4. Okay, yeah, 1 to 4 f of xi and delta x. You can write that way too if you like. Now let us substitute the value f of 2. We already calculated f of 2 there in the table. Look at this table here, right there. So f of 2 is half, delta x is 1, f of 3 is 1 over 3 times 1, 1 over 4 times 1, 1 over 5 times 1. So how much is that all together? I need, please calculate this. So adding all of these, we got 1.283. Okay. So now my question to you is this area is overestimate or underestimate? Well, clearly it is underestimate because we are living, it's less than the actual area and we call it underestimate. So this area R4 is underestimate of the area. Okay, it is less than that. Method 2. Now method 3. So method 3 using midpoint. Okay, let us use the midpoint. And let me draw the graph again. Okay, 2, 3, 4. So we are going to approximate this area again. Now, if I look at the midpoint, so the midpoint is, as you know, that the midpoint, this one is 1.5. This midpoint is 2.5. This midpoint is 3.5 and this one is 4.5. So that will determine the height of the rectangle. So that means if I draw a rectangle there, okay, my height of the rectangle will be like this. So the first rectangle will be this one. Okay, the second rectangle height is this, that means it will be this. Third rectangle, the height will be this, that means this will be the rectangle, and here this will be the rectangle. So remember, we are using this rectangle, we are using this rectangle, we are using this rectangle and this rectangle. So let's see. So M4 using the midpoint using 4 rectangle. So the area of the first rectangle will be f of 1.5 times delta x plus f of 2.5 delta x plus f of 3.5 delta x plus f of 4.5 delta x, right? Now let us calculate what is f of 1.5. That is 1 over 1.5, and delta x is 1 plus 1 over 2.5, because the function is 1 over x. So f of 1.5 will be 1 over 1.5. F of 2.5 will be 1 over 2.5 plus 1 over 3.5 and times 1 over 4.5 times 1. So now I need your help to calculate how much that will be approximately. So once you add all of them, we got 1.575. Now, my question to you is this. Among these three values, L4, R4, and M4, which one is a better approximation for the area? Of course, by using the common sense, we can say that the midpoint, probably be the better approximation, right? We'll see that in a minute. But in general, well, let's calculate the exact area first, and then we'll compare that. So how to find the exact area? We'll be using the fundamental theorem of calculus. That's what we will be discussing in our next lesson in more detail. But I just want to give you a heads up, okay? I just want to tell you what is the exact area and how we will calculate this, okay? So exact area, this is how we can calculate. Exact area is 1 to 5. The formula is this: a to b f of x dx. So our a is 1, b is 5, the function is 1 over x dx, and we already know how to find the antiderivative of this, okay? Again, we will discuss this in the next section in more detail. So we call it fundamental theorem of calculus part 2. So what that theorem tells us is that in order to solve the definite integral, you just find the antiderivative of this, okay? Antiderivative of this, you can also write 1 over 5 x power negative 1 dx if you like. We know that the antiderivative of x raised to power negative 1 is ln x, and so ln x, and you just copy this limit 1 to 5. We just write the limit like this, okay, using the the vertical line. Sometimes we can write this way too, ln x. We can write this way too, 1 and 5, either this or this notation doesn't matter. So what it means is we substitute the value of x, the upper limit first, minus substitute the lower limit. That's what it means. So we'll get ln 5 minus ln 1 is, okay, can you use your calculator and let me know what is the value of ln 5? So we know that ln 5, if you punch the button in your calculator, it's going to give you 1.61. Minus, if you punch ln 1, you'll get 0. So that means the actual area is 1.16. That is the exact area. Now let us compare all these three areas. So our exact area is 1.16. Using the left endpoint, we got 2.083. And we say that this is more than the actual area. And actually this is more, right? Because you can compare that. And we say that the right, when we use right endpoint, we got that. And we say that this is a underestimate, which is actually less than the actual area. And yes, you can see that. And if you look at this, among these three methods, midpoint is better approximation to the exact area. And in general, that is the case, okay? In general, midpoint gives better approximation. So Any questions so far? So in this example, we approximate the area. We found the approximate area by using three methods, using the left hand point, right hand point, and midpoint. And we also we also found the exact area by using the fundamental theorem of calculus. And we noticed that midpoint is, midpoint gave a better approximation to the actual area. Okay. Example 2 is very similar to this one, and I trust that you can do it by yourself. I leave it to you. But before we move further, I want to ask you one question. Instead of dividing 4 rectangle here, if I divide this into 10 rectangle, what do you think? The area will be a better approximation or a bad approximation in that case? Of course, it is better approximation. So if we increase the number of rectangle, then we'll get, as you can see here, for example, in this case, we have, what we did is we have a function here. And we did from 1 to 5. So we divided that into 4 rectangle and we calculate. Now, if we divide this into 10 rectangle, for example, so in that case, our approximation will be better. If I divide this into even 20 or maybe 30 rectangle, if I divide it into, let's say, 100 rectangle, I'll get better approximation. Okay, because if you draw that, rectangle here, you see you are not leaving, pretty much no space is left out, right? You see, when you draw the rectangle, if you make lots of rectangle, then that will give a better approximation. So if I want to get the exact area, how many rectangles should I need to consider? Well, the more rectangle I consider, the better approximation. And so if I want to get the exact area, then I will consider infinitely many rectangles. So area is given, exact area is given by I runs from 1 to n, but what is n? So the more n I consider, the better result, the better approximation I get. So I'm going to consider n tends to infinity. Okay, so if I consider n, number of rectangle infinitely many, then I'll get the exact area. Okay, and we also discussed at the beginning of the class that the exact area is represented by this definite integral. So this is a very important concept, guys, and this sum is called a Riemann sum. Okay, the name of this one right here is Riemann sum. Riemann is a great mathematician, and he figured out how to find the area, and he came up with this idea. So when we take n tends to infinity, then we'll get the exact area. Okay, so this is called Riemann sum, and this is the definite integral. And if you want to find the area, then we can use this definite integral. All right, now let's go all the way down to example 3. So in example 3, the question tells us find the exact value of the integral using formula from geometry. So we know that the definite integral represents the area. Okay, so let me do part A first. So what it means is if I draw the graph for this function, okay, so 5 plus x 1 to 3, you know how to draw the graph, right? So 1 2 3 4 5 there, and so this is your 5 here. So basically the graph will be like this. This is my function. Let us suppose that this is our function f of x or y. for that matter. Okay, this is my f of x. So we draw the function f of x. Now we want to find the area from 1 to 3. So 1 is here and 3 is there. So basically we are trying to find this area right there. Now use your high school concept and try to find the area of this shaded region. So remember, in order to find this line and this line are parallel, you can find the area a couple of ways. One is that you divide it into rectangle and the triangle, and some area of rectangle plus area of triangle, or you can use the formula, trapezium formula, right? It's a trapezium. So area is given by, this one is your f of 1 and this is your f of 3. So you know from your high school that area of a trapezium is half sum of the bases, sum of the parallel sides, which is f of 1 plus f of 3 times width. And this width is basically, this width is, what is the distance? Is that 2? Yeah, times 2. You can find that way. So which gives me half. What is f of 1? So let us calculate. F of x is 5 plus x. F of 1 is 5 plus 1, which is 6. F of 3 is 5 plus 3, which is 8. So basically we got here 6 plus 8 times 2, and this 2 to cancel out. So your answer is 14. All right, so that is the area. Now suppose you want to use the fundamental theorem of calculus that we'll be discussing later, and let us look at that. And we just want to convince ourselves that the fundamental theorem of calculus, the definite integral, actually gives us the area. Okay, let us calculate, let us compute the definite integral. So to compute the definite integral, you know the antiderivative of this, which will be 5x plus x squared over 2, right? That is your antiderivative, and then 1 to 3. So what it means is, it means we substitute the upper limit first. So this means 5, 3 plus 3 square over 2. Substitute x, 3 for x, minus the lower limit, which is 5 times 1 plus 1 square over 2. Now I need your help. Please calculate, and how much do you get? So it is 14, right? So when you work it out, you're going to get 14. So we have seen that using the geometry and using this got the same thing. And it proves that the definite integral actually represents the area. Okay. Now let's try part B. In part B, we want to find area for this. So let us draw the graph of this one. So here, guys, here y equals 16 minus x squared is square root. That is our y. I want you to draw the graph of this function. Notice that this is actually 1/4 of a circle, right? Because this gives me y square equals 16 minus x square if you square both sides. So what you got here is x square plus y square equals 4 square. So this is actually the equation of a circle with center at the origin and radius 4. Okay, so if you draw a graph of this, it is a circle of radius 4. But remember, the domain here is from -4 to 0, and this is square root, its upper part only, from -4 to 0. So this means we need to erase this part, we need to erase this part, and we need to erase this part. So this is -4 and this is 0. So we are talking about this area only. Okay, -4 to 0 and under this. I trust that you know how to draw the graph and you have done this in your high school or pre-calculus. I don't think there is an issue for you. So now you can find the area easily, right? So area is, it's the 1/4 of a circle. So area equals 1/4 of circle. So area of a circle, you know that 4 pi r square. Sorry, pi r square. Right? That's the area of this shaded region. So 1/4 pi r means 4 here, 4 square. So that's going to give you 16 pi. Is that 16 pi or 4 pi? 16 pi divided by 4 gives you 4 pi. Okay, that will be your answer. Any questions so far? And the last question, example 4. Okay, the speed of a runner increase steadily during the first 3 seconds of a race. Her speed at half-second interval is given in the table. Find lower and upper estimate for the distance that she traveled during these 3 seconds. Okay, lower estimate and upper estimate. Notice that this function is increasing. Okay, so the functional value is increasing. Therefore, lower estimate is given by the left endpoint, upper estimate is given by the right endpoint because the function is increasing. Now the good news here is that the table is already given. If you look at the example 1 that we discussed earlier, so in example 1 we have a function, we have to draw the graph, and we have to calculate these values in a table. Now in this question, the good news is the value is already given in table. No need to draw the graph. So what it means is your x0 is given there, x1 is this, x2 is this, x3 is 1.5, x4 2.0, x5 2.5, and x6 3.0. And this value is your f of x0. This is your f of x1, f of x2, f of x3, and so on. F of x6. Now, in this case, we notice that the starting point A is here. The initial value of x, A equals x0 equals 0, B equals x6 equals 3, okay? And your delta x is the width of the rectangle, this difference between x1 and x0 and x1. So the delta x is x1 minus x0, which is given by 0.5 minus 0. So this is 0.5. So that is your delta x. Now to find L, okay. And remember, there are 6 rectangle here because x6, as you can see, n equals 6 here. And n equals 6. Now you find L6, and you know the formula, that is L6 is f of x0 delta x plus f of x0 x1 delta x plus f of x2 delta x f of x3 delta x f of x4 delta x plus left endpoint means you stop there. Okay, f of x5 delta x. Now substitute the value. F of x naught is 0, f and delta x is 0.5 plus f of x1 is 6.2, delta x is 0.5 plus area of the third rectangle is 10.8 times 0.5, 14.9 times 0.5, 18.1 times 0.5 plus 19.4 times 0.5. And let me know what is the value. So if you calculate this, you will get 34.7, and since the unit here is feet, then that will be 34.7 feet. This is our lower estimate. Lower estimate. Now I want you to find upper estimate on your own, okay? Upper estimate, find it by yourself, which is represented by R6. In upper estimate, we consider the right hand side, right hand point. So then the value will, the rectangle will have, the first rectangle will have 6.2, or maybe you can write x1 delta x plus f of x2 delta x All right, guys, complete this yourself. So when you calculate this, your upper estimate should be 44.8 feet. Okay, I'll leave it to you. And so this section is done.